Hello students, welcome to botany class. So today we are seeing the problematic questions in the molecular basis of inheritance. So in this, the very first question here comes on your screen. How many guanines are found in the double-stranded DNA that has 700 hydrogen bonds and 10% adenines? Okay, so if this is the question, how to solve the problem we are going to see right now. Okay, so in this, what they have said already, that is the 700 hydrogen bonds are there in the double-stranded DNA. 700 hydrogen bonds are there. And in that, 10% are of the adenines, what they are saying. If 10% are of adenines, then 10% should be the thiamine. Okay. This is the Chargaff's rule. According to the Chargaff's rule, purines plus pyrimidines is equals to divided by 1. That is the purines and by divided by pyrimidines is equals to 1. Or else, whatever, how many purines are there, that should be equivalent to the pyrimidines. Like that also we can say. Okay, so with this one, that is the in the purines, adenine plus guanine are there, and the thymine and the cytosine in the pyrimidines. In the purines, adenine and the guanine. So in this, what we have to do now, how many purines and how many pyrimidines? So here they have given as the adenines as the 10%. That means cytosines are of the, and which type of bond they will make? Adenines always double bond they will make. Okay, adenines bonded with the thymine with the double bond. So this is the one, and the cytosine always pairs with the guanine with the triple bond. So with this simple one, you can use the equation as the 2x plus 3y is equals to 700. What we are having the hydrogen bonds. And in this 2x means the double bonded molecules of the nitrogen bases. That is the adenines and the guanines. So 2x, how many are there right now in the 700? Those are of the 10%. That means 2x is equals to how to calculate 700 into 10 by 100. So it should be, it will be the 70 nitrogen bases will be present. Okay, 70%, 70 will be the 2x value. That is the adenine value. Now, 2x directly we can put in this formula so that 70 plus 3y is equals to 700. Isn't it? 70 plus 3y is equals to 700. And 3y is equals to 700 minus 70. That means 630 is the value. And y is equals to 630 by 3. That is the 210. So how many guanines can be seen right now? 210 in the out of 700 hydrogen bonds, what was given in this problem. So this is the simplest way. So how to do it very fast right now, I am showing you. Okay. So once I clear the screen, then it will be very easy. In the 700 hydrogen bonds, okay, 10% are the adenines. Now, adenines will make the double bond. So the equation will be 2x plus 3y is equals to 700. Okay. And then 2x, how much? 700 by 700 into 10 by 100. So this calculations we should do it as 70 very fast. Okay. In the 700, how much is the 70%? 70. So that comes as 2x value. Then 3y is equals to 630. It should be very fast. 700 minus 70 because it is present here. Then it goes to this side, means it becomes the negative value. And y is equals to 210. That is guanines are of 210 in number in the complete double stranded. That's the one what we have to say here. Right? Now we will go with the second question. What is the second question in the problems? how many hydrogen bonds formed between two strands of DNA of 170 angstroms length if the cytosins are of 20%. If this is the case, then what to do? Okay, so here we are saying it as the 700 angstrom, 170 angstroms is the length of the DNA, and 20% are the cytosins what we are having. So write down here as the 170 angstroms is the length of the DNA, and in that 20% are the cytosins. And if the 170 angstroms is the length, then what is the base pair length in the standard DNA? That is a 3.4. So 170 divided by 3.4 angstroms. So if we will solve this one, we are getting the 50 base pairs. Okay, base pairs. That means 2 strands, what we are saying. So it should be again, if the cytosins they have given as the 20%. So guanines will be 20% again. So total 40%, isn't it? So guanines are also of 20%. So total 40%. So in the 50 base pairs, how much of the 40%? That means 50 base pairs into 40 by 100. Then it comes as 20. 0, 0, 0 gets cancelled. It's the 20 hydrogen, 20 base pairs will be present. So in this 20 base pairs, it is a triple bond now. So 20 into 3, 60 hydrogen bonds is the one from here. Now in the 100%, 40% are of the adenines and the cytosine and the guanine. Okay, then we have to calculate how much is the adenine and the thymine. So remaining ones are the 60% in the 100%. That means 30 and 30 now. So total 60%. One second. So total is the 60%. So in this 60%, now we have to see. Now we have to see the one as the, in the 50 hydrogen, 50 base pairs, how much is the 60%? Okay, then it comes as 30 base pairs. So this will be multiplied with the 2 because it is having only two hydrogen bonds. 2 into 30, 60 total hydrogen bonds. So 60 plus 60, the DNA, the both all 4 will be present. So it is the 60 plus 60 that will becomes the 120 hydrogen bonds totally in this problem. Okay, like this we need to check it out to the solve the problems. So I'm saying again very easily. So see, the length of the DNA is 170 angstroms, and this will be should be divided with the length of the base pairs in the standard, the specific DNA. That is always a standard constant one as 3.4 angstroms. Then the value comes as the 50 base pairs. In the given question, 20% are the cytosins and 20% are the guanines. Total 40%. So 50 into 40 by 100. That becomes the 20 base pairs. So this 20 base pairs will be having the 3 hydrogen bonds. That is the 60 hydrogen bonds. Okay, now comes in the 100%, 40% are the cytosins and the guanines. So remaining 60% should be the adenine and the thymine. So 50 into 60 by 100. Then it comes as the 30 base pairs. So 30 into 2, 60 hydrogen bonds. 60 plus 60, 120 total hydrogen bonds that are present in the specific length of the DNA strand. So like this, we will do the rest of the problems in the next class. Okay, right? Thank you. And if you are having any problem in understanding or anything, then you can put a query. Otherwise, you can ask in the comment box so that I can give you the specific solution, right? Thank you.